So what we're going to do now is talk about how to draw a line and how that connects to the linear model. So first, if I ask you for the equation for a line, what would you say? You might remember from geometry class. You might have said y equals mx plus b. This is how we learn to draw lines in school. The linear model is indeed a line, so all of our models are going to take this form. But instead of saying m, right, we say beta 1 or beta sub 1. And instead of saying b, we say beta sub 0. We also change the order around, so we get y equals beta sub 0 plus beta sub 1 times x. All right, so let's talk about what is making up this line though. So the m in our line equation is the slope, and that's defined as rise over run, or the increase in y, rising, divided by the increase in x, you're running. Now the way to say this is as variable x increases x unit, y increases y units. So again, this is represented by that beta sub 1. Our intercept, which is b in this equation, and beta sub 0, is the value of y when x is equal to 0. Another way of saying it is where does the line cross the y-axis. All right, so what do you think the slope of this line is, right? How much does y rise for every run of x? So this line, the slope is 1 over 1. Another way to say that is as x increases 1, y increases 1. And then the intercept of this line is when y, the value of y when x is equal to 0. Let me get my laser pointer again. So here is where the line is crossing the y-axis. Is also where x equals 0, y is 0. So that's pretty easy. All right, let's write this in equation form. So here's our fancy equation for the regression line. Instead of y equals mx plus b, we have y equals beta 0 plus beta 1 times x. And remember, our I indicates each individual value. But in this case, all of our values are going to be the same. So our intercept, beta sub 0, is 0 over here, and our slope is 1 over 1. So the equation for this line is y equals 0 plus 1x. So let's fill in this table just to check ourselves. So when x equals 1, what does y equal according to this equation? Well, let's put 1 into our x. So y equals 0 plus 1 times 1. So y should equal 1. And we can check over here. When x is equal to 1, then y is equal to 1. Hey, we got it. So good so far. All right, let's try it with 2. When x equals 2, y is equal to 0 plus 1 times 2. That's 2. So when x is equal to 2, y is equal to 2. Hey, that works. And then the last one for 3, y should be equal to 0 plus 1 times 3. That's 3. So here, when x is equal to 3, we follow our line out, y is also equal to 3. So our equation for our line is correct. If we applied all of these numbers to infinity and negative infinity and drew a line through them, it would match this line. So the takeaway here is that in simple linear regression, our model is always a line, and it has a slope and an intercept. So whenever you see an equation like this, you know how to interpret it. So let's look at an example with some pizzas. So here's what I just said. The model in a simple regression is a line defined by one slope and one intercept. So when x is 0, y is equal to beta sub 0. That's our intercept. And for our slope, for a 1 unit increase in x, y increases b1 or beta sub 1 units. So if we looked at our pizza and cost in dollars, and we had an intercept of 3 and a slope of 5, we would say when there's no pizzas, when you haven't ordered anything, your total cost is going to be $3. How did I get that? Right, so x is 0, so 5 times 0 is 0, so we're left with our intercept of 3. No pizzas, $3. Now, for our slope, for each one pizza, the cost increases $5. That's what our slope means. So that's for every extra pizza that we buy. But how much is one total pizza gonna cost? It's not gonna cost $5 because we have to add our intercept. One pizza is actually, 0 pizzas cost $3 and one pizza costs $8. So how much does 2 pizzas cost? We just fit it into our equation here. 3 plus, whoops. We're going to do 3 plus 5 times 2. 5 times 2 is 10 plus 3. So 2 pizzas is going to cost $13. One pizza costs $8 and 0 pizza costs $3. You have to remember when you're throwing these numbers in that the real world does not always match the hypothetical world of our model, right? So one thing is to think about whether a value of 0 for the x is going to make sense. This is our intercept. It may not always be a useful value. If you're thinking as a customer, you're not paying any money if you're not getting any pizzas. But maybe this makes sense if you're the business owner. Even if you're not actually making any pizzas, you still have to have staff come in that day. So there's a little bit of a marginal cost there. You always have to think about what's going on in the real world and compare it to what the numbers are showing. Don't just stick with the numbers. And another point here is that you want to use the units of x and y, right? So our y is dollars, right? So we talk about $8 and $13. And then we're talking about how many pizzas are x. We're going to use our unit of pizzas. So whenever you are interpreting an intercept and a slope, you can use these phrases. All right, so here's a line, and I have some questions for you. You're going to answer them in the quiz. The questions are going to be, what is the slope? What is the intercept? What's the correct equation for this line? What's the interpretation of the slope if you replace these numbers with the actual slope and intercept, or the actual slope and the units? And what's the interpretation of the intercept?